This will be about the totally confused mind of the optometrist. Lead lag, retinoscope, so forth, indirect, all of it's inventions, not reality, not scientific reality. But here's 25 minutes. If you have the time, listen to it. Here's 5 minutes of it.
And as promised, today we'll talk about the objective methods of measuring the lead and lag of accommodation and the accommodative response. The objective methods basically include various types of dynamic retinoscopies. So these are the monocular estimation method, also abbreviated as MEM retinoscopy. Then we have Knott's retinoscopy, Bell's retinoscopy, and Book retinoscopy. So let's try to understand these one by one. The first technique that we have is the monocular estimation method, or MEM retinoscopy. So, in the monocular estimation method, we are basically going to use magnetic fixation cards like these. Okay, so these fixation cards come with various targets, and these square cards can actually be stuck or attached to your retinoscope, and they are the ones which are going to use to measure the accommodative response using the MEM technique. Now, the main principle behind the MEM technique is that it is going to use the various lenses. So here we are going to neutralize the retinoscopic reflex when the patient is viewing a near target, and based on the lens with which we neutralize the reflex, we will assess the accommodative response. Okay, so this is an objective method. Here we don't rely on the patient's response. Instead, we also are neutralizing the retinoscopic reflex using various sort of lenses. So this is called monocular estimation method. Okay, so if to do this test, make sure that you use age appropriate material or toy, maybe for infant and toddlers, and these targets have to be placed at the patient's habitual near working distance. Okay, so in the previous video I talked about the near working distance to be 33 centimeters. Sometimes you take it as 40 centimeters, and in children you take it around 20 to 25 centimeter. It actually depends on the Harman's distance. The Harman's distance is what? It is the distance from the elbow to your middle knuckle or the third knuckle. Alright, next what you do is you will carry out your retinoscopy and you will look at the type of reflex that is seen, and now you start interposing the lenses monocularly. Okay, so although the patient is looking through both the eyes, you are putting the lenses only in front of one eye. Okay, so you're testing one eye at a time, and that is the reason why it is known as the monocular estimation method. Now, if you see with the motion, you are going to put plus lenses. If you see against motion, you are going to put minus lenses to neutralize the reflex. And here you really have to carry out your retinoscopy quickly. Okay, so quickly neutralize the reflex by placing the lens for no longer than half a second. Okay, we want to avoid, or we want to basically avoid altering the accommodative response or binocular fixation in these cases. Okay, the placement of lens is just for the examiner to neutralize the reflex and not for the patient to get used to that lens. And that is the reason why we're not going to put it for any longer than half a second. Now, after that, the lens that actually neutralize the reflex will represent the measured accommodative response. However, if your patient has astigmatism, you might have to neutralize the two major meridians separately. So I hope you understood what exactly is MEM method and how we are measuring the accommodative response using the MEM method. To summarize, you make the patient sit at a near distance, then you make them look at the age appropriate targets. Those targets can be fixed to your retinoscope. You scope one eye at a time, quickly introduce your corrective lenses, and based on the lens that neutralize the reflex, that lens is equal to the accommodative response. The normal range of accommodative response is usually plus 0.25 diopters to plus 0.75 diopters. In my previous video, I told you that a little bit amount of lag of accommodation is normal, and that lag of accommodation is 0.25 to plus 0.75 diopter. Okay, it indicates that the eye is slightly under accommodating, which is normal for sustained near work. However, the abnormal findings, when suppose you are interposing the lenses and you find that in order to neutralize the reflex in the patient, you have to use lenses greater than plus 0.75 diopter. It indicates that the patient has high lag of accommodation. Okay, so what does it mean? It means that there is under accommodation, or patient does not have sufficient amount of accommodation. And where do we see this? We see this in accommodative insufficiency, hyperopic patients, and even those who have convergence insufficiency. Then, if your reading of the lens is less than plano lens, or minus lenses are required. So if you're seeing excessive aghast motion and you're required to put minus lenses to stabilize that reflex or to neutralize that reflex, it means that the patient has lead of accommodation. It indicates over accommodation and usually is seen in accommodative excess or spasm of accommodation, right? So don't worry about all these terminologies. We'll talk about them when we talk about the anomalies of accommodation. Okay, so the advantages of MEM is that it's a really fast method, since you're putting the lenses really quickly, less than half a second, and fast, reliable method for assessing the accommodative response. Moreover, it's an objective method without really relying on the patient subjective feedback. All right, so that is your first type of dynamic retinoscopy, that is the monocular estimation method. Next, let's talk about the Knott's retinoscopy. So, what exactly is Knott's retinoscopy? So, in NEM, the target and the retinoscope both were placed at the same distance. But in case of Knott's retinoscopy, the retinoscope is at a different distance from the fixation.
Okay, it took me 10 years to learn all this interwoven complex words that only describe the refractive states of the completely normal eye, plus or minus, when I measure my normal eyes using a Snellen and test lenses. But this is 25 minutes long, so you should be able to listen to a full 25 minutes, and then we can talk about all the misconceptions that are involved in this using a retinoscope rather than objectively measuring your own refractive state yourself, as a good engineer would do it. What I do is objective, but only I can do it. If some third party wants to measure, they use a retinoscope, and that's third party. My measurements are personal and objective and very accurate to a quarter diopter, and I have vision. I said better than 20/20, meaning I can read the 20/20 line through a plus half diopter or plus 1 diopter lens. It's all gravy. Once you get to that point, I will use a plus for prevention, plus 2.5 for reading at 20 inches, and the equivalent of 4 diopters when reading at 10 inches, completely neutralizing accommodation in all cases. That's the goal. So if you have commentary, any study in the future would have to involve the engineer's intelligence, motivation, and goal, scientific goal, an understanding of the meta-eye, which means the eye as it actually is, not the invented eye using a retinoscope and misunderstandings of the dynamic behavior of the completely normal eye. So I'll let you sort this out. By all means, listen to the full 25 minutes of this video. If you have questions, go ahead and ask them. Thank you.